students, welcome back to the lecture series of inverse trigonometric functions, and this is our lecture number 4. And in this lecture I am going to discuss about some properties of inverse trigonometric functions. And so let's get into the video. Let us begin this video with property number 12, and up to property number 11 you can watch my previous videos, and in my channel you just search for inverse trigonometric function, and in the playlist you can obtain those videos. And also you can go to the I tab just at the right uppermost corner, just tapping that there you can also go to the playlist of the videos. So now let us begin this class by this property. So sin inverse x minus sin inverse y is equal to sin inverse of this one. Okay, so let me prove this one. Very simple proof. You see, let me take let this sin inverse x, this is equal to say a, and this sin inverse y, say let me this is b. So obviously this is implies x is equal to sine of a and y is equal to sine of b. And therefore since sin a is equal to x, therefore we can find cos a is equal to what? Cos a is equal to simply root over 1 minus x square. Very simple, because cos a is equal to root over 1 minus cos square x, and this will be positive as x is greater than 0. X is greater than 0 means sin a is positive, and it is in the first quadrant. X greater than 0 mean a is in the first quadrant. Similarly, y is in the first quadrant mean y greater than 0 mean angle b is also in the first quadrant. So cos a is positive, as well cos b, this is also positive, and that will be equal to 1 minus y square, because cos b equal to root over 1 minus sin square b. Now you see cos sin of a plus b, a minus b, so you can write therefore sin a minus b, this has the formula, it is in the first year class, sin a into cos b minus cos of a into sin of b. But using these values here, sin a is equal to x, sin b equal to y, cos a is equal to this one, cos b equal to this one. So this is implies, I can write here sin of a minus b, this is equal to sin a mean x and cos b mean root over 1 minus y square, minus cos a is root over 1 minus x square, and sin b is y. So I write y then 1 minus x square, and after that just take this sign on the right hand side as inverse function, you see here. So that is implies a minus b, this is equal to, must be sin inverse of x root over 1 minus y square and then plus y root over 1 minus x square. And finally you just apply the values of a and b, and that is sin inverse x minus sin inverse y, because a is sin inverse x and b is sin inverse y, is equal to, on the right hand side it is sin inverse of x into root over 1 minus y square, then minus y into root over 1 minus x square, and this is the proof. And here for x negative y positive or x positive y negative, that can be used but just by writing sin minus x is equal to minus of sin x, or cos sin minus y is equal to minus of sin y, and after taking those minus outside the inverse function, you can also use the formula for negative x and negative y also. So let me go to the next slide. Before that, I am clearing the screen. So this is the next property, cos inverse x minus cos inverse y is equal to this one, and it has some conditions here. if x greater 0, y greater 0 and x is less than y, then the formula is this one, simple formula. And basically this formula is used basically in other cases for x less than 0, y greater than 0, or for x greater than 0, y less than 0, and some other conditions also, x greater than y or y greater than x. In those cases you can use the formula just by applying the previous properties of inverse trigonometric functions. So let me prove this one. So let cos inverse x is equal to a and cos inverse y is equal to b. Very simple, as done in the previous screen. So x will be equal to cos a and y will be equal to cos b, and therefore sin a and sin b can be obtained from here. So sin a is equal to root over 1 minus x square and sin b is equal to root over 1 minus y square. And now this side is a minus b, and so cos a minus b formula we know that one. So cos of a minus b is equal to cos a cos b minus sin a sin b. So use these values here. This is sin a sin b and this is cos a cos b. Use that values here. So cos of a minus b is equal to, this is x, this is y. So xy minus this value is coming from here and this value is coming from here, this one. And now we verify these properties, x less than y and x greater than 0, y greater than 0. So very simple. Now x greater than 0 mean what? The value, highest value of x mean 1, because the range domain of the cos function is from minus 1 up to 1. But here I am taking x is greater than 0. So obviously it is from 0 to 1. Highest value of x is 1. So that is why I am writing here 0 to 1. Similarly, y is also greater than equal to 0. Mean it is also from 0 up to 1. Because you already know that one. Because for the cos function, you have this one, this cos inverse x, its domain was minus 1 less equal to x less is equal to 1. But in this question it is given that x is greater or equal to 0. X greater or equal to 0 mean it is confirmly from 0 to 1, and therefore from 0 to 1 it is the value of x. But x was taken as cos a, so we may take here is implies 0 less is equal to cos of x is equal to cos a, so it is cos of a less is equal to 1. And since cos a is a cos inverse a is a decreasing function, therefore cos inverse 0, this will be pi by 2, it will be greater than or equal to, then a greater or equal to, this is 0. So conformly I will get the value of a is in the first quadrant. This is the topic. In the similar way, value of y is also in the first quadrant. So that is written here. That is written here. You see here. This one, b is also here. And so a plus b, not a plus b, a minus b. This time it is a minus b. So a minus b is from minus pi by 2 up to pi by 2. How it is obtained minus pi by 2 up to pi by 2? You see here. You see here. It is up to minus pi by 2 up to pi by 2. How it is minus pi by 2? Already I told you that the value of a, it is from 0 to pi by 2. You see, this is the value of a, 0 to pi by 2. And the value of b is also from 0 to pi by 2. And so value of minus b will be from minus pi by 2, then minus b up to 0. Now adding this and this. So left hand side will be minus pi by 2, then it is a minus b only, and this is only pi by 2. That is why a minus b is in the range minus pi by 2 up to pi by 2. You got my point. Okay, and after that the second condition, using the second condition. The second condition tells us here, this is the second condition, x less than y. So if x less than y, then cos a is less than cos b, confirm. And so since cos a and cos b mean the cosine function, that is the inverse cosine function in the principal branch. Principal branch mean from 0 up to pi. In the principal branch, cos inverse function, this function is a decreasing function, and that is why when we eliminate this cos from both sides, then this inequality sign will be reversed. So a is greater than b, and this is implying a minus b is greater than 0. And here we obtained a minus b is in between minus pi by 2 and pi by 2, and here we obtained a is greater than 0. So conformly, if you take the intersection of these two, then a minus b will lie from 0 up to pi by 2. So that is, I am writing here. So a minus b is in the first quadrant, and in first quadrant cos theta is equal to cos theta, because first quadrant cos theta means it is positive, nothing else will be there. So therefore cos of a minus b is equal to 0, is equal to this part. Then cos can be taken on the right hand side as a inverse function, as an inverse function. So it is a minus b in the left hand side. Then cos inverse of all terms are there. Then cos inverse, this is a mean cos inverse x, and this is b mean cos inverse y. It is taken here, you see. And on the right hand side, you see cos inverse of the terms are remaining same here, only xy minus root over 1 minus x square and 1 into root over 1 minus y square, and that is the proof of the theorem. And now we take the next one. This is an important formula. Tan inverse x minus tan inverse y is equal to tan inverse of x minus y divided by 1 plus xy. And if this product xy is greater than minus 1, then we are to use this formula. And if this product is less than minus 1, that is the denominator. If the denominator is negative, actually this means the denominator is negative, because 1 plus xy is less than 0, and xy greater than minus 1 means the denominator is positive. So if denominator is positive, that is xy is greater than minus 1, then the formula is direct result. And if this is less than minus 1, then the result is pi plus something. So I am going to prove this one. It's very simple actually. As done earlier, you just take this is a and this is b. So tan inverse x equal to a and tan inverse y is equal to b. From here x is tan a and y is tan b. And a and b, what is a? A is equal to tan inverse x, and tan inverse x function range, tan inverse x function range is minus pi by 2 up to pi by 2, minus pi by 2 up to pi by 2. So both of the functions, both of the angles a and b, both these two angles are between minus pi by 2 and pi by 2. And after that, you see we need a minus b. Therefore you see here the formula for a, tan a minus b is this one, and then this is x, this is y, it is x plus xy. You just apply that one. Tan a minus b is equal to x minus y by 1 plus xy. So let me mark it by 1. And after that we use these conditions. The first one, so case 1, when xy is greater than minus 1, and in that case you see xy greater than minus 1 mean what? Actually it mean if x greater than 0 and y greater than 0, then a is from 0 to pi by 2. The concept is same. Actually a is from minus pi by 2 up to pi by 2, but since x is positive, mean tan a is positive, therefore you are to take the angle a from 0 to pi by 2. The concept is very simple, and b is also in that way, 0 to pi by 2. Then a minus b, it is in between minus pi by 2 up to pi by 2, discussed in the previous screen as like that. And after that you see a minus b will be, this one implies a minus will be, this is actually minus pi by 2 up to pi by 2, this is actually the range of tan. So tan function will remain, tan of something will remain the same, that is tan a minus b is equal to this part. Then tan can be taken on the right hand side as inverse function like this. So a minus b is there, this a minus b is there, equal to right hand side is tan inverse of x minus y divided by 1 plus xy. But a is what? A is equal to tan inverse x, so I write here tan inverse x, and b is equal to tan inverse y, so I write here tan inverse y is equal to this one. So this is the proof for the case 1. Now we take case 2. This is important actually. You see, if x greater than 0 and y less than 0, and xy this is less than minus 1. Then what are the conclusions actually? You see here, x greater than 0 mean 10a greater than 0. You see, in this case x greater than 0 mean 10a greater than 0. 10a greater than 0 mean a should be in the range from 0 up to pi by 2. And how it is from 0 up to pi by 2, I just told you. And in the similar way, when y is less than 0, then y should be in the negative branch, mean the fourth quadrant, from minus pi by 2 up to 0. Now we take a minus b. This is b actually, but to get minus b, it will be 0 to pi by 2 only, 0 to pi by 2. So a minus b is in 0 to pi. Why it is 0 to pi? You just see here. You see on the screen. You see here. You see a. This is from 0 up to pi by 2, and here b, it is from minus pi by 2 up to 0. But minus b is from where to where? Minus b is from 0 minus b up to pi by 2. And so now adding these two, you will get 0 plus 0 is 0, a plus minus b is a minus b, and pi by 2 plus pi by 2 is pi only. So that is why a minus b is in this range. Okay. So after that you see, if x greater than 0 and y greater than 0, y less than 0, it also implies x minus y. X is a positive number and y is a negative number. So x minus y, it is a must case, mean x minus y is a positive number. So in the formula of 10a plus b is equal to x minus y, so numerator is positive. Actually the formula was what? In the equation number 1, you just see here, I am writing here. What was 10a minus b? In the previous screen you can see 10a minus b is equal to, it was x minus y divided by 1 plus xy. So I am telling about this. So x minus y, this is positive number, and 1 minus xy, it is the condition, this one. 1 minus xy is less than minus 1, mean 1 plus xy is less than 0. That means you see the denominator, this is less than 0 and the numerator is greater than 0. So the resulting term is a negative number. That is the conclusion. So you write that one. I am cleaning the screen here. You see, so 1 x minus y divided by 1 plus xy, this is negative number, mean less than 0. So 10a minus b, this was the value, this has the value 10a minus b. So 10a minus b is less than 0. So 10a minus b less than 0 mean a minus b must lie from pi up to pi by 2 up to pi. ASTC, by the rule ASTC, you see here. In the first part we already obtained that a minus b is where? A minus b, this is in the range, this one, sorry, it is open interval, and here we obtained that a minus b is less than 0. A minus b, 10a minus b, not a minus b. So 10a minus b less than 0. That means what? 10a minus b less than 0 mean the angle a minus b is either in the second quadrant or in the fourth quadrant. But it cannot lie in the fourth quadrant because actually a minus b is from 0 to pi. So this option is already cancelled. So it must be in the second quadrant. Second quadrant mean it will start from pi by 2, then a minus b, and it will finish at pi. So this will be the range for a minus b now. So that is I am writing here. So this is the conclusion for that. A minus b is in between pi by 2 up to pi, mean the second quadrant. So since a minus b is in the second quadrant, therefore in equation number 1, you see the equation number 1, it is in the left hand side is 10a minus b. So we cannot directly use a minus b is equal to the formula. That means this one, actually I am telling about this. The equation number 1 was what? You see here, equation number 1 was 10 of a minus b is equal to x minus y divided by 1 plus xy. This was the equation number 1. Now you see it is a minus b is in this part minus pi by 2 up to pi, but actually for inverse trigonometric function the range of tan function is, or tan inverse function is from minus pi by 2 up to minus pi by 2 up to pi by 2. This equal sign will be not there, this one. So here we obtained a minus b is from pi by 2 up to pi, but actual range is this one. So therefore this a minus b should be taken in this range. That is the main condition actually. So pi by 2 up to pi, then to get in this range minus pi by 2 up to pi by 2, I am taking a pi minus in all sides. That is the actual one is pi by 2, then a minus b, then pi. Take a pi minus in all part, that is pi by 2 minus pi. I am writing like this, pi by 2 minus pi, then a minus b minus pi, then this will be 0. That is the concept actually. Then again take a negative sign into here. So this is 0 less than pi minus a minus b, then less than pi by 2. So I am using this now for the formula. Okay. So tan a minus b minus pi equal to this one. You can also write that one, that is the last line, mean minus of tan pi minus a minus b. That is also correct. You may use any one of that. So a minus b is equal to taking the tan inverse function on the right hand side, and finally pi is taken on the right side. So a and b is already used here. A is equal to tan inverse x and b is equal to tan inverse y, and pi is going to the right side, so it is a positive function, positive number pi, plus the function is tan inverse x minus y by 1 plus xy, and that is the proof for the function. And so I finish this video here, and in the next class I will take some more properties, and that will be the last part of the property section of inverse trigonometric functions, and then I will take some problems, and those problems actually based on the JEE main and JEE advanced. So I will not discuss about the NCERT based question in those classes. So therefore you are to keep with my channel, and it will be helpful for your upcoming JEE main or JEE advanced exam. So thank you very much for today.